Hi, hi, hi. Good evening, good evening, good evening. Good evening, everyone. Good evening. How are you all? I hope everyone is fine and doing good. So, my name is Ramesh Babu. I have completed my BTech from VVIT, which is located in Guntur district of Andhra Pradesh. Okay. So, let me share my screen here. Okay. Wait a second. I'll share my screen here. Entire screen I am sharing now, so that we can start our session. So I can see two people in the chat box. Please respond in chat box whether it is audible or not. Whether it is audible, can you see my screen? Please respond in chat box. Can you see my screen? Hello. Please respond in chat box. Can you see my screen? Let me check whether we are live or not. Please give me 1 second. Let me check whether we are live or not. Yes, we are live. Yes, audible. Yes, audible. Yes. So last classes, what we have discussed once see what we have discussed in last classes. We started with inequalities. We have started with inequalities. We have started what is inequality and what is equation. Difference between an equation and an inequality we have seen. So basically, any expression which is having equals to sign is called equation, and any expression which is having an inequality sign is called an inequation. So here we have started our session one. Here we have started our session one, and after that interval and its representation, union of two intervals, intersection of two intervals, rules for solving inequalities. These are all we have seen in the first session. So second session we have started with Wavy curve method. So basically we will use the Wavy curve method for solving inequalities of linear type, and the rational inequalities also we will solve by using this Wavy curve method. Okay, so rational inequalities we have completed in second session. And the third session of basic maths we have started this logarithms. Third session of basic maths we have started this logarithms. So what is a logarithmic function? Basically, any function will take input and it will give output. So that is the work of any function. So what logarithm will do? Logarithm also will take some input and it will give some output, and it is another way of writing the exponential function. So exponential function and logarithmic function are inverse to each other. Okay, exponential function and logarithmic function are inverse to each other. We can write exponential function as a logarithmic function, and we can write a logarithmic as a exponential function. So how to write and how to convert exponential to logarithm we have seen in last classes. Okay, and properties of logarithms also we have seen. What is the domain and what is the range, and equations of logarithm. This everything we have covered in the last classes. Okay, so logarithm inequalities, and with the two PYQs we have concluded our session, which is a basic maths lecture 4. Okay, so with the two PYQs we have concluded our logarithms concept. So what we are going to discuss today? What we are going to discuss today? Do you have any idea what we are going to discuss today? What is the next topic here? What is the next topic in basic maths? One is inequalities, another one is logarithms. So coming to the another topic, which is a modulus function. Okay, modulus function is also very important, which we will discuss in basic maths itself. And modulus function application is throughout. It will be useful in throughout your JEE preparation. Okay. So without wasting any time, we will start our class with the modulus function. Okay. So what we are going to discuss today? Today we are going to discuss about a modulus function. What is the definition of modulus function and how it is useful? How to open modulus function? Graph of modulus function and inequalities of a modulus function. We will see in this class. Okay. So clear. So once again, I welcome you all to the Basic Maths Lecture 5. Today we are going to discuss about a modulus function. So let me write a heading here, a modulus function. Today we are going to discuss. Okay. So modulus function. Today we are going to discuss about the modulus function. Okay. So what is the definition of this modulus function? What is the definition of a modulus function? What is the definition of modulus function? One second. Okay, modulus function. Is there any lag from my side? If there is any lag from my side, you can comment in chat box. Okay. If there is any lag, you can say it in chat box. Once confirm whether is there any lag from my side. You can see chat box here. Is there any lag? You can see here 1 second. I hope there is no lag. Live chat I can see here. Once tell me whether is there any lag or not. Live chat also I can see here. Okay. So modulus function. So how to denote this modulus function? F of x equals to mod x. So f of x equals to mod x. So with this we can write f of x equals to mod x. Yes. So f of x equals to mod x. This is a modulus function. Okay. So f of x equals to mod x. This is how we will denote this modulus function. So how to read it? Read it as mod x. Simply we can read it as mod x. Okay. Read it as mod x. Okay. So what this modulus function will do? This modulus function also will take input and it will give output like all the other functions. So what is the basic work of a function? Basic work of a function is to take input and to give output. So like all the other functions, this modulus function also will take some input and it will give some output. So what inputs it can take? What are the inputs it can take? So any real value we can give as input for this modulus function. Any real value we can give as input for this modulus function, and this modulus function will take that value as input and it will convert it into positive number. Okay. So what is the work of a modulus function? Modulus function will convert modulus function will convert input to the positive values. So what is the work of a modulus function? It will convert the negative numbers to the positive numbers. Modulus function converts negative numbers to the positive numbers. Okay. So note down this point. A modulus function converts negative numbers to positive numbers. Okay. That is the work of this modulus function. Okay. And internally, what is this modulus function will do? Positive numbers. So negative numbers to positive numbers. Okay. So internally, what is the work of the modulus? Internally, what it is doing? So internally, what it is doing, it will apply a negative sign to the negative quantities. Okay. Internally, internally, modulus function will apply a negative sign to the negative quantities. So modulus function will apply a negative sign to the negative quantities. This is how it will convert the negative numbers to the positive numbers. So modulus function will apply negative sign. Somewhat lag is there, okay, but no problem. Modulus function will apply negative sign to the negative quantities. So what it will do, it will apply negative sign to the negative quantities, so that output will be positive. What will happen if you apply negative sign to the negative quantities? It will become a positive quantity. So basically f of x equals to mod x, read it as mod x, and modulus function, what it will do, it will convert the negative numbers to the positive numbers. And how it will convert? It will apply negative sign to the negative quantities, so that output will be positive. So that output will be positive. So for example, if we see, one second, if we see, for example, modulus of minus 5. What is the modulus of minus 5? For example, modulus of minus 5. So modulus of 5 will be equals to 5 only. Modulus of minus 5 will be equal to 5, but internally what it is doing, modulus of minus 5, first it will open with the negative sign, which is minus of minus 5, so that output will be 5. Okay, this is what internally happening, but directly we can write a modulus of minus 5 is equals to 5. And what about another example, modulus of minus root 2? So what is the answer for this modulus of minus root 2? Modulus of minus root 2 is plus root 2. So internally what it is doing, it is applying one more negative sign for this minus root 2, so that output is positive. So if we give 3 as input, will it apply negative sign for 3? Can anyone tell me in chat box, will it apply negative sign for this 3? Will it apply negative sign for 3? Once tell me in chat box. I can see here in chat box. No, it will not apply negative sign to the 3, because 3 is already a positive quantity. So it will not apply negative number to the 3, so that output is as it is, we'll get it as a output. Okay, so modulus of 3 will be equals to 3 only, without applying negative sign. It will give as it is output. And what is modulus of 0? Modulus of 0 will be also again 0 only. So for negative quantities only, modulus will apply negative sign. For positive quantities, directly it will give positive only. For example, what is the value of modulus of root 2 minus root 3? Can anyone tell me the answer for this modulus of root 2 minus root 3? What is the answer for this? Mod root 2 minus root 3. Modulus of root 2 minus root 3. So we know that root 2 value is 1.4 and root 3 value is 1.7. So 1.4 minus 1.7, which is a negative quantity. Okay, 1.4 minus 1.7 will give negative quantity. So what is this? What will this modulus will do? This modulus will apply negative sign to root 2 minus root 3. Okay, so that what is the output? Output will be root 3 minus root 2. So this is output. Modulus of root 2 minus root 3 will be equals to root 3 minus root 2. So internally what it is doing, it is applying a negative sign to the negative quantities only. Positive quantities, it will give positive quantities as output. Okay, so what is another example? For suppose log 5 base 2 is there. What is the value of log 5 base 2 modulus? First of all, tell me whether log 5 is a positive quantity or a negative quantity. Log 5 is a positive quantity or a negative quantity. What is the value of log 4 base 2? Already we have completed a logarithms session, which is a basic maths lecture 3. You can see this logarithms. Log 4 value will be equals to 2 and log 8 value will be equals to 3. So log 5 value lies between 2 and 3. This log 5 value lies between 2 and 3. So we know that it is a positive quantity and the modulus will not perform any operation on positive quantity. Directly whatever the input we give, same output it will give. Okay, so for negative quantities only it will apply negative sign. For positive quantity, as it is output, it will give. So one more example, which is a modulus of pi minus e. Modulus of pi minus e. What is the output of this modulus of pi minus e? We know that pi value is 3.14. And what is the value of e? E value is 2.71. Okay. So 3.14 minus 2.71, again it will give positive quantity only. So modulus of pi minus e is same as pi minus e. What about modulus of e minus pi? See this example, modulus of e minus pi. E is nothing but Euler number and pi is 22.3.114 or 22 by 7 values we can use. E is Euler's number whose value is 2.71 and pi value is 3.14. So what is the value of this modulus of e minus pi? What is the output of this modulus of e minus pi? 2.71 minus 3.14, which is a negative quantity. So this modulus will apply negative sign for this e minus pi, so that output will be minus of e minus pi. So what is minus of e minus pi? Minus of e minus pi is pi minus e. Okay, this is how modulus will do operations on these negative numbers. So clear about this modulus function. What is the work of this modulus and how it will do operations on negative quantities. So once again, see the definition here. Modulus is a kind of a function which we will use for converting the negative numbers to the positive numbers, and the modulus function will apply negative sign to the negative quantities so that output is positive. And several examples also we have seen how it is converting negative numbers to the positive numbers. Okay, so how to open this modulus function? How to open this modulus function? For suppose mod x is there. For suppose mod x is there. how to open this modulus? Mod x can be opened as plus x if x is greater than 0. Okay, if x is greater than 0, mod x will be open with plus x, and mod x value will be equals to 0 if x is equals to 0. Okay, and modulus of x will be equals to minus x if x is less than 0. Okay, so how to open this modulus function? Modulus of x will be open with the plus x if x is greater than 0, and mod x will be equals to 0 if x equals to 0, and mod x is equals to minus x if x is less than 0. This is how we have to open this modulus function. So till now it is clear how to open modulus function and what is the work of a modulus. Modulus is a function which converts the negative numbers to the positive numbers. Okay, so examples and how to open the modulus we have seen. Now we will move to the next topic, which is domain, range and graph of the modulus function. Okay, we'll move to the next topic, which is the domain, range and graph of the modulus function. Okay, so what is this modulus is doing? Modulus function, what it is doing, it will take input and it will give output. So if we give minus 5 as input, if we give minus 5 as input, it is giving 5. If we give 0 as input, it is giving as it is 0, and if we give any positive number as input, it is giving the same number. Okay, so this is how the modulus is working. Now coming to the next topic, which is domain, range and graph of the modulus function. So what is the domain and what is the range and what is the graph, how it will be, we will see in the next topic. So you can write down side heading here, domain and range, domain comma range, domain comma range and graph of the modulus function. Okay, so domain, range and graph of the modulus function. So what is the domain of this modulus function? What is the domain of this modulus function? Any input we can give as a domain, any input we can give to the modulus function. So what is the domain? Basically we know that a domain is a set of x values for which function is defined. So domain is nothing but set of x values. Since everything we can give as a domain, domain is from minus infinity to infinity. Okay, everything we can give as input for this modulus function. So each and every real value we can give as input from minus infinity to infinity. So from minus infinity to infinity, any value we can give as input to this modulus function. And what is the range of this modulus function? Range of this modulus function is only positive real values. Okay, all positive real values including 0. So range is all real positive values including 0. Okay, so all positive real values including 0 is the range of this modulus function, and domain is from minus infinity to infinity. Any value we can give as a input. So how the graph of this modulus function will be? Let us consider one simple example. Y is equals to mod x Let us consider a simple example y equals to mod x. And how to draw this graph of y equal to mod x? How to draw the graph of this y equals to mod x? So just plot some points. If x equals to 0, what is the value of y? If x value is 0, what is the value of y? Y value also obviously 0. So we got one point 0 comma 0. If x is 1, y is also 1. If x is minus 1, y is also 1. Okay. If x is minus 1, y is 1. If x is 2, y is also 2. If x is minus 2, y is 2. So here we got some points. So by plotting these points in the graph, we can draw the graph of the modulus function. So graph of the modulus function will be like this. Take x-axis and y-axis. So this is x-axis and this is y-axis. On x-axis, take some points 0 comma 0. Suppose this is 1 and this is 2 and this is 3. Here minus 1, minus 2 and minus 3 also will be there. So here 1, if we can take 1, here 2 and here 3. So what are the points we need to plot here? 0 comma 0 is the first point. Then if x 1 comma 1 is the second point, so graph need to pass through this point, and here 2 comma 2 point will be there, and here minus 1, x is minus 1 and y is 1, graph will pass through this point. X is minus 2 and y is 2, so graph will pass through this point. So graph of modulus function will be like this, somewhat like this. So here with this pen tab, it is not clear, but it will be in the form of a V shape. So what is the graph of this modulus function? It will be in the shape of a V-shaped graph. So V-shaped graph, okay. Graph will be in the form of a V shape. Vertex will be at origin. Okay, this is the graph of this modulus function. If you can see, x values are from minus infinity to infinity, and y values are from 0 to infinity. So domain is nothing but set of x values, and range is nothing but set of y values. So domain is from minus infinity to infinity, and range is from 0 to infinity. So this is the domain, range and graph of the modulus function. Okay. So domain is from minus infinity to infinity, range is from 0 to infinity, and graph of this modulus function will be in the form of V shape. So coming to the next topic, which is how to open the modulus function. How to open this modulus function. So next topic is how to open this modulus function. So opening modulus function, I can keep side heading opening modulus function. Yes, opening modulus function. Any lag is there? So please respond if there is any lag. One second, some lag is there. Let me open this whiteboard again. Give me a second. Let me open this whiteboard again. I'll refresh all these tabs. So before going to the next topic, give me a second. Once I'll refresh the tab. So system was very slow today. So is it clear? Can you see now? Can you see the screen here? Okay. So everything perfect, right? Yes, I hope it is perfect. So, how to open this modulus function? How to open this modulus function? Opening a modulus function, okay? One second, it is not coming. Okay, opening modulus function. Need to change this Microsoft port. Opening modulus function, okay? So how to open this modulus function? For suppose we have modulus of some value, modulus of some expression we have here, like modulus of some box is there, okay? Modulus of some box is there. How to open this modulus box? Modulus of some expression is there. So this modulus of expression will be opened with positive expression. Modulus of any expression will be opened with a positive expression if that expression is greater than or equal to 0. Okay, if that expression is greater than or equals to 0, it will be opened with a positive, and that expression will be opened with a negative sign. So this modulus will be opened with a negative expression if modulus of this expression is less than 0. Okay, so modulus of this box will be open with the plus box if box is greater than or equals to 0, and the modulus of this box will be open with the minus box if a box is less than 0. Okay, who is this Akhilesh Dhulam? So hi, if you have any doubts you can ask in the chat box. Okay, so how to open this modulus function? So modulus function will be opened with the plus of expression if expression is greater than or equal to 0, and modulus of this box will be open with the minus box if box is less than 0. For example, we can see here, for example, if we have modulus of x minus 1, for example, if we have modulus of x minus 1, for example, we have modulus of x minus 1. So how to open this x minus 1? How to open this modulus of x minus 1? Modulus of x minus 1 will be opened with x minus 1 if x minus 1 is greater than or equal to 0. So what is the meaning of x minus 1 greater than or equal to 0? Meaning of x minus 1 greater than or equal to 0 is nothing but x is greater than or equals to 1. Okay, and this x minus 1 will be opened with 1 minus x, which is a minus of x minus 1. So minus of x minus 1 is anyway 1 minus x. If x is less than 1, if x is less than 1, modulus of x minus 1 will be opened with the negative sign, and if x is greater than or equal to 1, modulus of x minus 1 will be opened with x minus 1. Okay, so I hope with this example it is clear how to open this modulus function. Okay, so coming to the next topic, graphical transformation of this modulus function. If you have any doubts till here, you can let me ask. Okay, you can ask in the comment box. If you have any doubts, you can ask in the comment box. So coming to the next topic, which is a graph of modulus function. So till now, any doubts? Till now, any doubts on how to open this modulus function and the graph of this modulus function? So once again, let me show what we have discussed here. Just the just the definition of modulus function we have completed and examples. And what is the domain, range, and the graph of this modulus function, and how to open the modulus function also we have completed. Now we are going to the next topic, which is graphical transformations of graph. Graphical transformations of this modulus function. So graphical transformation of this modulus function. Okay. How to draw the graph of this modulus function in separate cases. Graphical transformations. Okay, graphical transformations we will see now. Graphical transformations of a modulus function. Graphical transformation of the modulus function. Okay, so vertex of the graph of this modulus function will always be at critical point. So where will be the graph of where will be the vertex of this modulus function? Vertex of the modulus function will always be at a critical point. Okay, just remember this point. This is very useful while drawing the graph of a modulus function. Okay, so vertex of modulus will always be at a critical point. Please note down this point. Vertex of modulus graph. Okay, vertex of modulus will always be at critical point. Okay, so what is this critical point? Vertex of modulus will always be at critical point. So what is this critical point? Can anyone tell me what is the critical point in chat box? Vertex of modulus will always be at critical point. So can anyone tell me what is the critical point in chat box? What is the definition and what is meant by critical point? Critical point. So critical points are the points where the expression is becoming zero. So suppose if we consider modulus of some expression, modulus of some expression is there. So what is the critical point? The critical point are the points where this expression inside of this modulus. Okay, the expression inside of this modulus is becoming zero. Okay, so what is the critical point? Critical points are those points at which the expression is becoming zero. Okay, critical points are those points at which the expression inside this modulus function is becoming zero. So one by one we will see the graphs of these modulus functions. So first one we will see graph of y equal to modulus of x minus 1. How the graph of y equals to modulus of x minus 1 will be there. So how this graph of modulus of x minus 1, how to draw this graph? So first of all, tell me the critical point of this. Critical points are those points where this inside expression is becoming zero. So equate x minus 1 to 0 to know about a critical point. So x minus 1 equals to 0 will give critical point. So what is the critical point here? At x equals to 1. At x equals to 1 we will have a critical point. So how to draw this graph of y equal to mod x minus 1? Just draw take one y-axis, take one y-axis and x-axis. Okay, just to take y-axis and x-axis. So x equals to 1. This is a point x equals to 1. Here vertex will be there, and from here v-shaped graph will be there. So from x equals to 1, v-shaped graph like this, graph of y equal to mod x minus 1 will be there. So this is the graph of y equals to modulus of x minus 1, and the critical point will be at x equals to 1. Because at x equals to 1 only, y equals to 0. So at x equals to 1 is a critical point of this modulus function. And what about y equals to modulus of x plus 2? Y equals to modulus of x plus 2. How to draw the graph of this modulus of x plus 2? Can anyone tell me the critical point of this modulus of x plus 2? So can anyone tell me what is the critical point of this modulus of x plus 2 in chat box? Yes, I can see chat box here. So the expression at which it is becoming 0 is called the critical point. So x plus 2 equals to 0. So x equals to minus 2 is a critical point for this modulus example. So for this example, x equals to minus 2 is a critical point. So take x-axis and take y-axis. Take x-axis and y-axis. X equals to minus 2 is a critical point. So at minus 2 vertex will be there, and from here v-shaped graph we can observe. Okay, so graph of y equal to mod x plus 2 will be looking like this. X equals to minus 2 critical point will be there, and from there right side and left side the same v-shaped graph we can observe. So this is the graph of y equal to mod x plus 2 and y equal to mod x plus 1 and mod x minus 1. Okay, so suppose if they give modulus of x outside plus 1. Okay, is it clear? Y equals to mod x, outside we have plus 1. How to draw the graph of this y equals to modulus of x plus 1? First of all, what is the critical point here? Critical point is where the expression is becoming 0 inside this modulus, where it is becoming 0. So at x equals to 0, this modulus expression will become 0. So x equals to 0 is the critical point. If x equals to 0, what is the value of y? If x equals to 0, if x equals to 0, value of y is equals to 1. If x equals to 0, value of y equals to 1. Okay, so from here graph will be like this. Okay, this is a point is 0 comma 1, x is 0 and y is 1. Here the point is x is 1, y is also 1. This point is x is minus 1 and y is 1. So if you see here, graph of this modulus moved upwards. Okay, this graph, v-shaped graph, moved upward one step. Okay, one step upward. One more graph we will see, which is y equals to mod x minus 1. So how the graph of this modulus of x minus 1 will be there? So how to draw this graph of y equal to mod x minus 1? If we give x value as 0, if we give x value as 0, y value will be equals to minus 1. So if we give x value as 0, y value will be equals to minus 1. So vertex will be at 0 comma minus 1, and the right side it will be extended like this, and left side also it will be extended like this. V-shaped graph symmetrically about a y-axis, since it is a even function y equal to mod x, since it is even function it is symmetrical about the y-axis. Okay, all even functions are symmetrical about y-axis. So from these four graphs, what you observed here, what we have observed here from these four graphs, what we have observed from these four graphs. So if we give y equals to f of x minus k, graph is moving one step to the right side. Okay, suppose y equals to f of x is our function. Suppose y equals to f of x is our assumed function. Okay, so this is our assumed function. What will happen if we add k to the x? Okay, what will happen if we add k, some constant? If we add some constant to the value of x, graph is moving to the left side. Here you can observe. Okay, so from this graph you can observe. From this graph you can observe V shape is moving to the left side. Okay, from this graph you can see this V shape is moving left side 2 units. Okay, so y equals to f of x plus k. If we give plus value to the x value, graph is moving 2 units to the left side. And if we give minus 1 to the x values, graph will be moving to the 1 unit right side. And outside, if we add a positive value, graph is moving 1 unit upward. And outside of this modulus, if we give negative value, this graph of this modulus is shifting downwards by 1 unit. Okay, this is how graphs of these modulus function will be shifted upward, downward, or left and right. Okay, left shift, right shift, and upward and downward of these modulus functions can be done by adding values of constants to the x value. Okay, by adding constants to the x value, we can perform this graphical transformations. Okay, clear? So till now, if you have any doubts, you can ask in chat box. If you have any doubts on these graphical transformations, if you have any doubts, you can ask here. So after this, we have properties of properties of a modulus function. So basically, modulus function we can split over multiplication. For suppose modulus of AB is there. Okay, suppose modulus of xy also you can consider. So modulus of AB can be written as modulus of A. Modulus of AB can be written as modulus of A into modulus of B. Okay, modulus of AB can be written as mod A into mod B. You can separate the modulus for A and B. Okay, you can separate the modulus for A and B. For suppose modulus of A by B is there, or modulus of x by y also you can take. I am considering modulus of A by B. So modulus of A by B also you can separate it as mod A divided by mod B. Okay. So mod A divided by mod B. Okay. So modulus we have modulus we can split in multiplication, and in division also we can split this modulus. Okay. Modulus of xy can be written as mod x mod y, and modulus of x by y can be written as mod x divided by mod y. Okay. So till now, if you have any doubts, you can ask in comment section. Okay. So far what we have seen. So far we have seen what is the definition of this modulus function and some examples how this modulus function is working and how to open modulus, domain, range, and the graph of modulus function, and graphical transformations also we have seen here. Okay. So next topic is modulus inequalities. Modulus inequalities is the next topic. Let me see how much time we have completed. So just 40, 50 minutes. Yes. So 50 minutes ago we have started this live. So once we'll go to Desmos and we will see how these graphical transformations are working. Okay. Once we will see Desmos, we will see how these graphical transformations are working. So let me open my Desmos here. Desmos basically we will use for seeing the graphs of functions. Okay. So here Desmos is open. You can see the graphs of y equal to mod x and everything. So suppose if I enter y equals to mod x, suppose if I enter y equals to mod x, where is modulus? Yes, here it is. Y equals to mod x. So this is a graph of y equals to mod x. You can see here it in red line. Okay. Here you can see the graph of this y equals to mod x in red line. Vertex will be at 0 comma 0. Vertex will be at 0 comma 0. Vertex will be at 0 comma 0, and this point is here. If x equals to 1, y is also 1. X equals to 2, y equals to 2, and x equals to 3, y is also equals to 3. Left side also similar graph you can see. Okay. So this is a graph of y equals to mod x. This is the graph of y equals to mod x. One more graph if we see, one more graph, one more expression, y equals to mod x. Inside of mod x I am giving plus 1. Okay, inside of this mod x I am giving a plus 1, mod x a plus 1. Now graph will be shifted to the 1 point left side. Okay, suppose if we give 5, so graph is moving 5 units to the left side here. Here you can observe clearly the vertex of the graph is moving 5 units to the left side if we give, if we add any value to the modulus. Okay. So one more expression if we see, now we will give modulus of x minus 5. Modulus of x minus 5, how the transformation will be? Graph will be shifted 5 units to the right side. Okay. So the green one is mod x minus 5. So this red one is a mod x, and this blue graph is for mod x plus 5. One more expression if you take which is mod x outside plus 1. Okay, this already we have seen through manual drawings. Okay, now we are seeing in Desmos. So what is this modulus of x plus 5 will give? Okay, so this modulus of x plus 5, this violet color. So this violet one is modulus of x plus 5. One more expression I will type for you. Modulus of x minus 5. So modulus of x minus 5 is black. Okay, here if you see this black graph, this is for modulus of x minus 5. This is for modulus of x minus 5. Okay, and lot of transformations we can do. For suppose if we give, if you multiply this modulus of x with 2, if you multiply this modulus of x with 2, here again you can see red one, this shrinked. Okay, so initially y equals to mod x is wide one. Now if you multiply this x with 2, it is shrinked by somewhat some length. Okay, this shrinked red color is called y equals to modulus of 2x. Okay, this shrinked one. Let me clear this y equals to everything. Let me clear this one so that it will be looking good. Okay. So initially y equals to I will change this color also. Let me change the color of this y equals to modulus of 2x. So here, if you see y equals to modulus of 2x, if you multiply with the constant value, graph will be shrinking. Okay, graph will be shrinking. And if you divide with the value, divide with 2, what will happen if you divide with 2? It will become narrow. Okay, if you divide with the 2, it will become narrow. Okay, so 1 by 2 into x, 0.5x also we can give 0.5 x. Now it is becoming wide. Okay, so this violet one is half x, and this blue is modulus of 2x, and the red one is initially y equals to mod x. Graphs will be at vertex y origin only, but see the transformations here. If you multiply with the constant value, if you multiply with the constant value, it is becoming narrow, and if we multiply with a value which is less than 1, it is becoming wide. Okay, so these are the graphical transformations. I hope with these graphs it is very clear how this graphical transformation is performing. Okay, so clear this one? Yes, I hope it was clear. So graphical transformations also we have completed here. Okay, so coming to the next topic, which is modulus inequalities. Modulus inequalities, we will see next topic. Okay, so we have 7 types of modulus inequalities. At least I'll try to complete two in today's class. Okay, yes, we have time. So totally we have 7 types of modulus inequalities. We will see these modulus inequalities in 7 types. So first type is first type will be somewhat like this. So modulus inequalities is the next topic. Modulus inequalities. So how many types of modulus inequalities we have? So far we have categorized these modulus inequalities into 7 types. Most of the questions will be based on these 7 types only. Other than this, no other types are there. Okay, so most of the questions will be framed on these 7 types only. So first one is in modulus inequalities. The first type is modulus inequalities. The first type is mod x less than or equals to k, and mod x greater than or equals to k. Okay, suppose mod x less than or equal to k and mod x greater than or equal to k. With example we can see the type 1. In type 1 with one example we can see here. So suppose mod x less than 1, mod x is less than 1. What is the solution of this inequality mod x less than 1? What is the solution of this inequality? Once we will open this modulus with the plus sign, so that x less than 1 is one condition, and one time we will open this modulus with the negative sign. So x less than 1 and minus x is also less than 1. So x less than 1 and minus x is less than 1. So what is the meaning of x less than 1? X is a number from minus infinity to 1. What is the meaning of this minus x less than 1? Minus x less than 1 is nothing but x is greater than minus 1. So what is the intersection of these two, x less than 1 and x greater than minus 1? If we see intersection of these two, which one is x less than, one is x less than 1 and another one is x greater than minus 1. So x is greater than minus 1 and x is less than 1. If we see intersection part of these two, one is x greater than minus 1 and one is x less than 1, where the intersection of these two intervals it is, intersection of these two intervals is nothing but x belongs to minus 1 to 1. Yes. Hi, hi, hi. Hi, Seturagon. If you have any doubts, you can ask me in the chat box, okay? So, what is the common interval for this x greater than minus 1 and x less than 1? It is minus 1 to 1. So, solution for this inequality is x lies between minus 1 and 1. Solution for this inequality is x lies between minus 1 and 1. Okay. So, this is a solution. Mod x less than 1, solution is x lies between minus 1 and 1. Similarly, if we see mod x greater than 1, what is mod x greater than 1? Solution of mod x greater than 1 will be, what is the solution of mod x greater than 1? Mod x greater than 1. So one time open with the positive sign and next time open with the negative sign. So if I open with the positive, x is greater than 1, and if I open with the negative sign, minus x is greater than 1. Okay, minus x is greater than 1. So x is less than minus 1. Okay, so one interval is x greater than 1 and another interval is x less than minus 1. Okay, so minus 1 less than minus 1 is this side, and from 1 to infinity. So this is how we will split mod x greater than 1. So mod x greater than 1 meaning is x can be greater than 1 or x can be less than minus 1. But what is the meaning of mod x less than 1? X should lie between minus 1 and 1. So if we generalize this concept, what will come? If we generalize these concept mod x less than 1 and mod x greater than 1 with another expressions, so generalization. So if we generalize these topic, okay, is there any lag? Yes, okay. So if we generalize this modulus inequality type 1, which is modulus of some expression, is less than some constant we have. Okay, mod x less than k is one type inside type 1, and another category is mod of some expression is greater than some constant. Okay, greater than some constant. So this is another category. This is first category in type 1 and this is the second category in type 2. So what are the answers for these? Mod x, mod of expression is less than k and mod of expression greater than k. So by observing here, mod x is less than 1. So similarly here also mod of expression is less than 1. One time open this expression with the positive sign and once again open this expression with the negative sign. So after opening this expression with the positive sign and negative sign, this expression should lie between minus k and k. Okay. So this expression should lie between minus k and k, where k is any constant value. So how to solve this type of inequalities? Modulus of any expression is less than k, modulus of any expression is less than k, and modulus of any expression is greater than k. Okay. So if you see questions of this type, just remember modulus of this expression. Expression should lie between minus k and k, and mod of expression greater than k, meaning is expression is less than minus k. Okay, expression is less than minus k, or expression is less than minus k, or this expression is greater than k. Okay, by using this mod x less than 1 and mod x greater than 1, we have derived the generalization for this type 1, which is modulus of expression less than k and modulus of expression greater than k. So what is the meaning of this modulus of expression greater than k? Modulus of expression greater than k means this expression should less than minus k, or expression should be greater than k. So expression lies between minus k and k if modulus of expression is less than k. So on this topic we will see some questions. Okay, any lag is there from my side? So I can see no lag. So no lag is there. So understood clear concept here. Modulus of any expression less than k means that expression should lie between minus k and k, and modulus of any expression greater than k means the expression is less than minus k, or expression is greater than k. Like this you have to solve the inequalities of type 1. So with a small example we will see this type 1. For example, for example, modulus of x minus 3 greater than or equal to 2. Modulus of x minus 3 is greater than or equals to 2. How to solve this modulus inequality? See, modulus of this expression is greater than or equal to some constant. So, what are the two conditions here? First condition is x minus 3. X minus 3 should be less than or equals to minus 2, or another condition is x minus 3 should be greater than or equals to 2. Okay, so this modulus inequality we have divided into two types, which is x minus 3 less than or equals to minus 2 and x minus 3 greater than or equals to 2. And how these two expressions came? How these two expressions came? Once by opening this modulus with a positive sign. Okay, by opening this modulus with a positive sign, x minus 3 is greater than or equal to 2. By opening this modulus with a negative sign, again by multiplying with the negative on both sides, x minus 3 will be less than or equals to minus 2. So after solving these two inequalities, what we will get? We will get x is less than or equals to 3 minus 2, which is 1, or means always union, x greater than or equals to 5. So this is the solution for this inequality, x less than or equals to 1 or x greater than or equals to 5. What is the meaning of this x less than or equals to 1? x belongs to minus infinity to 1. X belongs to minus infinity to 1. And what is the meaning of this x greater than or equals to 5? From 5 to infinity. Okay, or means always union we need to consider for these two expressions. Okay, so greater than or equal to union we will take, and less than we will take intersection of two intervals. Okay, so here you can observe, if less than is there, here if less than is there we will take intersection, and for greater than we will take union of the two intervals. Okay, so I hope type 1 is clear for you. I hope type 1 is clear for you. Okay, so remaining types we will see in next session. System was lagging today. Okay, so till now if you have any doubts you can ask me in chat box. Till now if you have any doubts you can ask me in chat box. System was lagging. So I hope type 1 is clear for you, and six more types in modulus inequalities are there. Those six more types we will see in the next session. Okay, so one more session it will take for basic maths. Total six classes, right? So already we have completed 5 sessions on basic maths. Till one more session it will take to complete a basic maths. Okay, so only type 1 we have seen, which is a modulus of expression less than some constant, and modulus of expression is greater than some constant. Okay, so this is a type 1. So remaining six types are there. So six types of modulus inequalities is still remaining. Total seven types of modulus inequalities are there. These remaining inequalities we will see in the next class or next session. We can plan for these remaining six types of inequalities. Each type I'll explain the concept, and with one example we can move to the next type. Okay. So within one more session, I'll complete a basic maths. Actually, I have planned for taking PYQ series in this channel from today, but unfortunately, need to prepare slides, so it was delayed. From tomorrow onwards, I'll try to take a PYQ series parallelly to this basic maths. Okay, basic maths lectures will complete one more session. Within one more session, we will complete a basic maths, and parallelly we will start a PYQ series also from tomorrow onwards. Okay, so that's it for today. Let me stop this live session and stop this sharing screen. So that's it for today. Okay, so that's it for today. Bye guys. Good night. Good night. Good night. Good night, everyone. Tomorrow onwards, I'll start PYQ series of JEE Mains. With the straight lines, we can start tomorrow. Okay. So I stopped sharing my screen, right? Yes. So that's it for today. Good night. Good night, everyone. Good night. Bye. 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 Good night. Good night. Good night. Yes.